far talking about AI in terms of autonomous and driving the vehicle. I'm going to shift a little bit and talk about AI to understand the car consumer. And a lot of the same principles obviously still apply, and try to demystify AI a little bit. It's been going on for a long time, as a bunch of the speakers just talked about. It's really just linear algebra, and we'll talk about some of those applications and some of those assumptions. So these are basically the three ingredients that I'm going to want to talk about in terms of what Quantifind does and in terms of really every AI application. You have to know what you're optimizing for, right? And you can do that in a rule-based way, and we'll talk about some of those limitations in terms of training set and saying, we're looking for, this person, this animal, every time this person shows up, that's what we're optimizing for. The better way to think about that is not having to manually tag all that data and still know what you're looking for, right? So can you optimize for not getting into an accident, not hitting the cone, actually knowing what drives sales or what actually gets people to use rideshare or to get into an autonomous vehicle? I think one of the things that, that we believe pretty deeply in terms of technology adoption is often less about the paradigm shift and technology innovation, but really a big part of it is whether people adopt it. And that human element is something that AI can help solve as well, and we'll talk a little bit about that. The unknown unknowns, right? So people talk about unsupervised machine learning versus supervised. Really what that means is, can we find things that we didn't think we were looking for? And if you're looking at 1 million photos and you're labeling dogs, then you're going to find dogs, right? How do we think about creating parameters that let us find the things that we weren't looking for? That's really when AI gets exciting. And the last part is you need a feedback loop, right? And that feedback loop can be manual. It can be people saying, no, you got this wrong. That feedback loop could be an autonomous vehicle crashing into the wall. That feedback loop can also be, do people adopt technology? Do they buy the car? Do they use rideshare instead of buying their car, right? These are all feedback loops, and we're going to talk a little bit about how some of those feedback loops help us understand what people want to do, what that consumer wants to do. So unlike a bunch of the other bigger companies that presented today, you probably never heard about Quantifind. So I'll take a little bit of a step back, just give you guys a little bit of origin of the company. We started out of Stanford Atomic Physics Group and basically launched an initial company called Entanglement Technologies, which builds trace gas sensors for explosives, for air quality, stuff like that. What you're optimizing for is you're trying to find something pretty bad in the air, right? Whether it's RDX, explosives, or whether it's benzene. And you have a massive noisy background, similar to what you have in social media, right? Crazy amounts of conversation. Most of it doesn't actually really matter, right? In an AI kind of LiDAR environment, right, you're looking at all sorts of images. Most of those don't really matter to what you need to do on the road. So how do you figure out what matters? It was actually kind of cool because recently, with the hurricane in Houston, there was a benzene leak out of a Valero refinery. And they tried to do some estimates and figure out how much leaked to the environment. And Valero said, don't worry, it's all good. We barely leaked anything. Everyone can move back into the adjacent neighborhoods. Some of the NGOs didn't totally believe that analysis, and they actually invited our sensor to drive down to Houston as really the only sensitive enough device to be able to be on the ground in real time to show that they were off by a factor of 80 or something in terms of what that benzene contamination was. So again, what you're optimizing for, can we find this benzene signal, right, in a background of incredible noise? So let's fast forward a little bit to what we do in terms of understanding what people want to do. So Quantifind got pulled into sort of understanding the human intention through a meeting with Disney before these two movies. So spring of 2012, probably nobody in this room has heard of John Carter. It was, don't admit that. It was Disney's biggest bomb in the history of 100 years of movie making. 2 months later, Avengers opened up, right? And talk about signal and noise. You have millions of conversations on YouTube and Facebook and Twitter about what people are going to do. And they look the same, right? So leading up to John Carter and leading up to Avengers, those conversational signals all look the same. So is listening to human intention totally worthless because we can't tell the difference between the total extremes of biggest failure ever and biggest success? Or is there a better way to do it? So again, what's your optimization function? What are you trying to figure out? What you're really trying to figure out is who's going to buy a ticket to the movie, right? You don't really care if someone loves the trailer or thinks some actor is cute. You really care if they're going to buy a ticket. So there's your optimization function, right? You want to discover the unknown unknowns of why they're buying, right? So you don't know what questions to ask. You don't know to say, hey, are you going to see Avengers because of this superhero? It could be some reason you don't know about. And the feedback loop. The feedback loop, unfortunately, in the movie business, you get one shot in that opening. But the feedback loop is to next movies, right? How do we learn what actually drove people? So we can probably offline afterwards, I'll be here for a little bit, we can dig in a lot deeper in terms of kind of how we view the AI methodology to really understand what part of what people are saying actually influences what they do. So again, you want to find the things you weren't looking for. That's an unsupervised machine learning LDA clustering approach. Take all the conversations that are out there and turn them into a few hundred variables that might matter. The next thing is which of these hundreds of variables that might matter actually do. Well, again, what's your optimization function here, right? So if your optimization function is don't hit into the wall, well, let's figure out what variables help you avoid hitting the wall. If the optimization function is help me to buy a car instead of use rideshare, help me adopt autonomous vehicles, help me not default on my loan for a car, right? That's a different optimization function. But again, it's the same thing, and feedback is data keeps coming in, and let's figure out what's driving it. So here's just a nice, simple illustration of why most of the things we say don't actually matter, right? So if you look, it's a little bit faint here, but there's sort of this white mountain range in the background of conversation about a restaurant brand. The green line is their sales. You would have a really hard time finding any correlation between those conversations about the brand and their sales data. But there are hidden signals in there, right? And really what our product does is finds that, right? So if I'm looking at millions of conversations, how do I find that 15% of conversation that actually is a good predictor? Now, there are all sorts of sort of causality versus correlation problems here, and you have those in AI for autonomous driving as well. And you can never prove causality in any AI system. All you can do is get the error bars lower, right? All you can do is basically do lots of out-of-sample testing, lots of cross-validation, to basically get more and more confident that the thing that you think drives the result is very unlikely to be random, right? And you can do that for signals you're getting from the road. You can also do that from things people say on Twitter or Reddit or Facebook as well. So here's an example of working with one automotive company, what actually drives sales. And again, right, look at all this conversation about the brand, divide that in, discover these unknown topics, hundreds of them, and then figure out which actually are predictive. And again, this is dynamic, right? These things change over time. They change with each campaign. They change with ride sharing, disrupting the environment. If you look at the one all the way on the left, interior, so for this particular brand, focusing on the interior of the car drove sales with a really confident p-value. For the category in general, it didn't, right? So what this brand was actually able to leverage, they had a major competitive advantage in terms of focusing on the interior. So that's what you want to put in your campaigns and your messaging. That's what gets people to actually buy this car. What was a little concerning to them was safety features and quality were not there, right? So this was a brand that actually had prided themselves on quality for many generations. But here was the disconnect between what they thought their customers thought about them and what their customers actually thought about them, right? You want to know that as soon as you can. And again, looking at all the conversation about your brands, it's hard to pull out that signal. Finding the part that's predictive of actual sales, that's where you want to zoom in on. And these things change dynamically. That's part of the feedback loop, right? Find the topics and the drivers. Ride sharing was not a confident p-value back 2 years ago. And some of the stuff we're doing now, for some of the brands, it really does matter, right? These things are dynamic and changing. You need to have that feedback loop and the ability to find the topics that you didn't know to be looking for. So really, there's two sides of the equation for how Quantifind thinks about the world. There's all this really messy conversational data, and that's really what we focus on because we're really trying to get at what are people going to do, right? As opposed to on whether the car is going to crash into a wall. And then there's the optimization function on the other side, right? And that's a well-defined metric that basically replaces training, right? I don't need to label every picture and say my optimization function is improve the precision of my ability to find a cat. I'm basically labeling my outcome by saying what's predictive of this outcome, right? So I'm using this time series, this optimization, this business metric that I care about to actually be my training set, right? And then merging all these data sets of conversation and what you're trying to achieve, whether it's sell more cars or improve the, the autonomous experience, merging those sets gets you something really cool. I'm going to skip through these, some of the interest in time. This is just one example that I like to cover. Taco Bell's been a customer of ours for a long time. They launched breakfast to compete with McDonald's, smashing success early on. Every focus group, tweet, Facebook post could not be happier with the bacon chalupa breakfast taco that they launched, right? But sales started dropping, right? So here's the disconnect between all the noise of what people are saying and their actual purchase behavior and what they do, right? And again, every study Taco Bell did showed super positive response from their customers. So we turned on our product, and here the optimization function is breakfast sales, right? Does it actually translate to selling more bacon chalupa tacos? And the topic that was discovered, again, unsupervised, we weren't looking for this, was conversations about coffee, right? Less than 10% of the conversations, but incredibly predictive of the drop in sales for Taco Bell breakfast. Mom basically got coerced by her teenage kids to go to Taco Bell a couple times and take them there for breakfast. She couldn't get a decent cup of coffee, and she basically said, all right, next time you're going to find somebody to eat at Starbucks. And that's what happened. And even though all the reviews, all the chatter, all this massive, kind of teenage upswelling loved what Taco Bell was offering, they couldn't get their mom to drive them there. So we showed this to Taco Bell, right? They were able to create a partnership with Cinnabon. Breakfast sales went up 6%, coffee sales doubled. It's that hidden signal of what's actually predictive, right? You have your optimization function, you're finding this unknown unknowns, and then you have feedback of actually saying, okay, I did this, right? Am I driving more sales? Just gonna skip through some of these. Happy to talk through more of these kind of topics afterwards. One thing we, on the automotive side, focusing on work we've done with Nissan, Nissan sponsored Star Wars Rogue, and this was a pretty major sponsorship, big commitment from both sides. And normally, brands will wait 3-4 months later to figure out, hey, did that do anything? Did it work, right? And you learn for next time. But what if you could learn for this time, right? What if you could actually look at all the conversations people are saying about Nissan Rogue while they're happening and use those as proxies for what their behavior is going to be? Now you can get a real-time feedback. Are we actually influencing people, right? Are we resonating with people? Which of our creatives are resonating with people to get to buy the Nissan? So they had a bunch of different creatives up in real time that they were launching in the context of the Nissan Rogue sponsorship. And in real time, we could help them figure out which ones were actually selling cars. On the influencer side, again, signal and noise. Do you want influencers with lots of followers, or do you want influencers that influence behavior, right? Those are very different. And as you think about building a brand, whether it's building your brand or influencing different behavior patterns in terms of adoption of autonomous, in terms of how we respond to rideshare, there are folks that have really large follower graphs. You're not optimizing for getting more followers. You're optimizing for behavior. How do you find the ones? You'd rather someone with 1 million followers that gets people to act than 10 million followers and doesn't. Skip through that. Just a couple other things, and then make sure we have enough time for questioning. On the automotive side, there are a lot of these class of problems that I think resonate with different folks across this room from some of the conversations that we've been having. Thinking about financing, right? So dealer oversight. Can you actually look at these applications? Can you look at look at Reddit and Consumer Fraud Protection Bureau stuff coming through about, hey, are dealers actually issuing bad loans? Is there a concern on the financing side? Can we find fraud on that front, right? If we want to have a healthy sort of automotive ecosystem, the finance side has to be good as well. And again, the unknown unknowns, right? What are the new forms of fraud that are emerging from some of these interactions? That a rules-based system that was talked about before, that gets outdated pretty quickly, right? This is classic TSA solving the problem that was last week's problem. How do we find next week's problem? Again, that conversational data, that really rich, although very noisy conversational data, when put together with a clear optimization function, lets you find those things that you didn't even know to be looking for. What about ride sharing, right? So ride sharing is a major concern with a lot of the automotive manufacturers we've been talking about. Again, where is there a threat and where there isn't, right? Who do we have to respond to? Are certain manufacturers more at risk than others? Is there a way to partner? Are there innovative business models that we can think about that makes this actually helpful as opposed to disruptive? Tough to find if you're looking for rules-based types of approaches, but lots and lots of people are giving you feedback every day about how they view rideshare in terms of their day-to-day and how they view purchasing the road car. A lot of it's noise, a lot of it doesn't actually impact their decision-making, but what if you could find that part that did, right? What if you could build these predictive models for car purchase, for rideshare usage, and understand who's actually influenced, how do we actually learn about what that behavior is and be able to get ahead of it. And then autonomous, and just sort of end with this because I think that was a large focus. Again, I kind of believe very deeply that paradigm shifts in technology, right? First you need that scientific breakthrough, but Google Glass is a good example of a brilliant technology breakthrough that has not really had any consumer adoption, right? Not for lack of good science, not for lack of good technology. Technology becomes disruptive when people use it and people adopt it. So how do we sort of get ahead of that and understand what people are going to do in terms of that technology adoption, right? What level of autonomous vehicle are people going to really adopt? It's great to kind of build these prediction curves, and every bank and every equity research shop puts one out in terms of like when technology is going to be ready, but when does it actually disrupt what people do and what people are comfortable with? How do we respond to that? How do we know which level of autonomous vehicles we need to bring to the market because they'll be adopted, right? Not because we can from a technology perspective. And being able to think about these perspectives from what people are going to do, again, from the AI application of what's your optimization function? It's vehicle adoption, it's vehicle purchase. The unknown unknowns of what's driving this that really you can only learn from a very unstructured, unsupervised type of environment, which is conversational data, people just talking, but it's incredibly noisy, right? And by sort of merging that conversation with the optimization function, you can find what actually drives it, and then you test and learn, and you feedback, and you get smarter, and that's kind of where the AI kicks in. So I'm going to stop here and leave some time for questions, but thank you very much.